Hi, I'm Christopher Dean. I'm the Technical Product Manager here at FastCap Systems.
And I'm Joseph Lane, the Director of Engineering at FastCap Systems.
So for ultracapacitors, a good feature to use them for is for relatively low power, relatively low voltage applications.
Yeah, this is kind of unintuitive because you wouldn't necessarily think of using an ultracapacitor for low power applications, but there are in fact quite a few. In exploration as well as in production a little bit, you see cases where you either want to provide power to a tool when the generator is off. So for example, if mud flow is off and you don't have power, and you want to power things like sensors, low power communication, logging and circuitry, real-time clocks, things like that. And then you have other applications where you want to power a sensor that's just in a location where it's not suitable to place a battery. Maybe you don't want to change out the battery every time it runs out, so you want something rechargeable. In that case, these might be low power applications that fit within this realm as well.
So you could also use things that maybe have longer lifetime that you'd want to replace them, or if they're even tough to get to, maybe they're on the board, circuit board, or they're in smaller form factor.
Yeah, so we see a lot of interest in providing power to these critical elements when mud flow is off or in those instances, and that's where these sort of design parameters around these low power, relatively small systems comes into play. Mm-hmm. So when we start down that path, usually the first thing we look at is how much size do you have available? What's your volume that you can work out of? If it's a great volume, if it's a big volume, great. The more space, the better.
Sure.
Yeah. But usually it's not that big.
Yeah.
So we have to work within that confined space.
Yeah. So what's the form factor going to be, and kind of how much spacing do you need, not only for the ultracapacitor to fit in, but the surrounding components? Maybe you need a housing, or maybe you need it potted, or something along those lines.
Yeah. So, and we have a bunch of off-the-shelf capacitors that we can put into a solution, but we can also do custom ultracapacitors for that given form factor, and this is something that we do a lot. You have this space, you have a certain performance level that you want to get out of it. So we'll actually design the capacitor specifically for that application, so you get the best performance, the longest lifetime, the highest power, highest energy, whatever, in that space. So after we figure out the general power and energy requirements to fit within that space, then we start discussing, what kind of electronics do you plan on having? Do you need to have inside of it?
Yeah. Where's the location going to be within the module or the entire system itself?
Yep, exactly. Because that will change, the temperature that it will see, the vibration, shock and vibration that it will see, and then what kind of power is actually being supplied to it.
Yeah.
A lot of times we'll do the input DC-DC converter. If it's a load that requires a fixed output voltage or one that can be unregulated, we'll either add or not add an output DC-DC converter. And then we'll discuss with the customer, okay, how are you going to mount these cells? Mounting is extremely important.
Mm-hmm.
I know you've run into a lot of different mounting.
Yeah, so there's, and that again was what I was saying before, is that the housing, you have to protect these cells from shorting together or shorting with the system. So if they are going to go in a big tube or a pipe, you have to isolate them from one another, as well as keeping them, stable and rigid, so the shock and vibration doesn't affect them or the electronics themselves.
Yeah. Usually for these low power applications, it's all about fitting it into a package that will work, and doing so very, very efficiently. The other thing that you run into a lot with these, low power, maybe ride-through voltage systems, sensor power systems, is leakage current on the capacitors. So this is something that's a little bit different from batteries as well. As they sit at voltage and temperature, they do leak current off of the cells. So you only have a limited time frame to use that energy. About what kind of leakage do we see?
So it varies between cell and also varies between temperature and voltage as well. So if you are going to charge to a higher voltage, you might get a higher leakage current, but also the form factor is important. And typically what we see is we can get down to the milliamp range for sure at high temperature and voltage, but also down to the nanoamp range, especially if you're, depending on the form factor and the internal components that we'll use within the capacitor will affect it as well.
Yeah, and what that means for the application is, you can charge up the capacitors and they'll be able to sit at that voltage for, hours, handful of hours, but they're not going to be able to, generally, they're not going to be able to sustain, high temperature, high voltage for days, weeks. So that just plays into the application.
But it does come up with a good interim kind of power supply when you have to turn the pumps off, or if you have a power, you have to cut the line or whatever. The ultracapacitors can act as a backup
10 minutes,
solution.
20 minutes, that's fine.
Yeah.
And it can provide power over that time frame.